In this video, we're going to be talking about rational exponents, about finding the indicated real nth roots and rewriting rational exponents in radical form. We're going to start off by finding the indicated real nth roots of a. So in our first example here, we have n equals 3 and our a equals -8. So because we're finding the nth root, what that implies is that the n is going to go right there. And here we see that we have an n value of 3. So we're going to put our 3 in here. So we're looking for the third root of our a value, which is -8. Because we're finding an odd root, it's okay that our negative is on the inside there. So the cubed root of -8 is going to be a -2. So I'm going to have you try letter B on your own. So go ahead and push pause, and when you're done, push play, and let's see if you're right. So here we have an n of 4, so we're looking for the fourth root of 81. So we want to know what number raised to the fourth power will give us 81. And that answer is the number 3. So the fourth root of 81 is 3. Let's talk about how you can rewrite rational exponents in radical form. When we're rewriting rational exponents in radical form, sometimes it can be helpful to think of it as dog pile. I like to think of it with the base is what always gets squished. Let's use a different color to make that a little bit easier. So our base is always getting squished, and how many times a day that actually happens. And this right here will indicate our family. So what we're doing is we're finding different roots, right? So we're finding different roots. And so this is kind of like the little squishy part, right? Let's try that again. This is like the little squishy part. If it moves in and out and in and out, it can like squish whatever's there. So what's getting squished is the 4. So the 4 is on the bottom of the dog pile here. It's a family of 16s that like to play this game, and they do it 3 times a day. So go ahead and you try number 27 on your own. It works the same. Push pause, and when you're done, push play, and let's see if you've got that set up right. So again, we're taking roots. The 3 is on the bottom of the dog pile, so it's what's going to get squished in our little house. It's a family of 27s that like to play the game, and they play it 4 times a day. So when we're finding 27 to the 4/3, we're actually finding the cubed root of 27 and then raising that answer to the 4th power. Let's do some examples that might help us out. In this particular set of examples, we're going to rewrite the expression in rational exponent form. So we're going to kind of undo what we just did. So notice here we have a family of 4s. And remember that they like to play dog pile. The 5 is who's going to get squished, and they do it. And we know that because it's what's inside right there getting squished. And they do it 3 times a day. So our 3 is going to go on the top of our fraction, and this is going to be our solution. Let's try it one more time. So here we have a family of -8s. They like to play dog pile. The 3 always gets squished, so it's on the bottom of our fraction. They do it 2 times a day. So it goes on the top of our fraction, and that's going to be our solution. I want you to try that third one, the 4th root of 15 to the 7th power, on your own. So go ahead and push pause when you're done, push play, and let's see if you were right. Here we have a family of 15s, and they like to play dog pile. And the 4 always gets squished, and they do it 7 times a day. And so we should have 15 raised to the 7/4 as our answer. Now in this next set of examples, we're going to rewrite the expression in radical form, which is what we just did before these last 3 little examples. So I'm going to have you try all 3 of these on your own. And when you're done, I want you to push play and let's see if you were right. So here, because we're rewriting it into radical form, we're going to need radicals. It's a family of negative 3's. The 5 is always getting squished, and they do it 2 times a day. So we can put the 2 here, or we can even put parentheses there, as we saw above. Either way, it's fine. That's going to be our first solution. Here, we're going to have a root, a family of 6's. The 2 is what's going to be getting squished. Now, because it's a square root, we actually don't write the 2 because without the 2 there, it's assumed that's a 2. So it's kind of like it's an invisible 2, and it happens 3 times a day. So we put our 3 right there, and that's going to be our solution. And again, you can put parentheses around that like that if you'd like to, but you don't have to. And in our last one here, we've got the root and a family of 12's. And here we see that the 4 is getting squished. And they like to do that 3 times a day. And again, we can put our parentheses here, or we don't need to. And that's our solution. And then these last 3 examples, we're going to practice evaluating the expression. So utilizing what we just did to evaluate. So here we have a 32 raised to the 2/5. So if we're going to evaluate that, we first need to rewrite it in radical form. So here we have a family of 32's. The 5 is getting squished, and they do it 2 times a day. So what are we looking for here? Well, we're basically looking for the 5th root of 32, and then we're going to square that. So if we're looking for the 5th root of 32, we want to know what number raised, so again, it's what number raised to the 5th power will equal 32. So what number raised to the 5th power will equal 32? And that answer is 2. So we're going to go ahead and we're say, okay, we have a 2, but we're not done. We still need to square that answer. So when we finish squaring that answer, that is going to give us a value of 4. And that will be our final answer. I'm going to have you try this next one on your own. So go ahead and push pause and work out the problem. And when you're done, push play and let's see if you were right. So to evaluate this, we want to first rewrite it as a root. It's a family of negative 64's. Here we have a base of 2. So we know that our 2 is getting squished and that we have a top of 3, so it's going to be happening 3 times a day. So the square root, remember we don't need to write this little square right here. It's kind of like an invisible 2. So I'm going to go ahead and get rid of that really quick. So the square root of negative 64. Well, we can't take the negative square root of 64 because that would be an imaginary number. So that's going to be no real solution, all because of that negative right there. So no real solution. All right, let's go ahead and let's move on to our third example. Here we have 343 raised to the 2/3 power. Let's just touch on that last one for a moment. If this had been not a square, but in fact to the 3rd power, we could have worked this out. But remember that whenever our root is an even number, that means that we cannot take a negative number there. And that's why we're left with the no real solution. So back to our 343 raised to the 2/3 power. We're going to be finding a root of the number 343. We see that our 3 is in the denominator, so we're taking the cubed root of 343, and then we're going to raise that to the 2nd power. So we want to know what number raised to the 3rd power is 343, or what is the cubed root of 343? And that number is a 7. So we're going to take our 7, and then we're going to square that. And that's going to give us an answer of 49. So here we can evaluate this out to a 49. Sometimes it can be difficult to know how in the world to get that 7. So one suggestion that I have would be to memorize the numbers 2 through 7 up to their third powers. Or if you have a calculator, you can simply put in and go, gosh, what is 2 to the 5th power? And see, does that work? Is it too low? Is it too high? Then maybe try a 4 to the 3rd power and see that. Does that work? And if it's not, keep going until you find your answer. So that's an option as well. It'll take you a little bit longer, but that's also an option.